Kind greetings to you all. This is Mwalimu Arnold Sekago, and today I am here to answer some questions from one of your colleagues. Now, there is one who requested me to briefly comment on colligative properties, and I am here to comment on them brief as she asked. So a brief about colligative properties. So by colligative properties, what do we mean? Basically, we refer to those properties that depend on number of particles, but not the nature of those particles. For example, I think I did not open this very well. Now I have to write in it. Let me first open another avenue. So I've been saying that if you have, for example, a solvent, say naphthalene. Okay, let me use the common one, water. So a colligative property, there are many properties which we can investigate. For example, if I have water, within this water, I put salt. Suppose that within this water, there are salt particles. There are many things which I can look at. If I have made this, the mixture will boil at what temperature, how the freezing point of this mixture be affected, the density, electrical conductivity of the solution. All those are properties which I can look at. But a colligative property, for it, these are properties that will depend on number of salt particles. Number of salt particles, how many grams of salt have you put here? Have you dissolved in water? But they do not depend on the chemical nature of this salt. Yeah. These are properties that do not investigate or are not interested in knowing the chemical nature of salt. The salt can be sodium chloride, potassium chloride, or any other salt. But for them, they are interested in establishing the quantity. And that quantity, I think it was also said in class, you can use it to deduce a lot of things, things to do with relative molecular mass. Yeah. So those are colligative properties in brief. It depends on number of dissolved particles, but not the nature of those particles. So what are they? Basically, there are four. There are four properties of investigation. We have vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So lowering of vapor pressure, increasing, elevation is increasing boiling point of a mixture, and lowering of freezing point of solute, and osmotic pressure. So we comment briefly about each. Now for I don't know whether my screen is visible. I cannot see it here. Oh, I did not share this. A moment. I thought that I've been on. You see, these are some of the